Hi, everybody. We are going to do the second half of 1.6. I'm going to get myself all situated. And I remember last time my face was super small, but I don't know, do you want me that big on your screen? Okay. I think that should be fine. Yeah. Okay. So here is the second half of 1.6. That's the answer key. All right, here we go. So Malcolm earns $20 per hour mowing lawns and $10 per hour walking dogs. So he has two jobs and they all contribute to his money. So we're gonna put these jobs together. His goal is to earn at least, so he doesn't want to make less than, he wants to make at least more than 200 a week. So greater than 200 a week, so let's remember that. At least, he could earn exactly 200 a week, that probably would make him happy. And he can work a maximum of 20 hours a week. That means he cannot go over 20 hours. He probably has other obligations. So he has to work less than 20 hours a week, right? So less than 20 hours a week, less than 20, maximum. He could work exactly 20. So let's put an or equal to sign underneath it. Okay. Malcolm must spend at least 5 hours per week walking his neighbor's dogs. For how many hours should Malcolm work at each job in order to meet his goals? So we're going to do that X is the number of hours mowing lawns. Y is the number of hours walking dogs. So the first one I'm going to do is a money inequality. Talk about all the money. My money from mowing lawn, his money from mowing lawns, his money from walking dogs, and his $200 that he wants to make. So here we go. If X is mowing lawns, then I'm going to say that 20X, $20 for mowing lawns. He also earns $10 for walking dogs. That's going to be 10Y. And he at least 200. That was greater than or equal to 200. Then it says he cannot work more than 20 hours a week. He cannot work more than this. So he needs to work less than or equal to 20 hours, right? So that's going to be his mowing lawns and his hours walking dogs has to be less than or equal to 20. Okay? He must spend at least, that's like at least more than or equal to 5 hours walking the neighbor's dogs. Okay. So I've organized my numbers, I've organized my information here. So now, write your 3 inequalities again. All right, here we go. I'm going to write them spread out, and I recommend you do the same. X plus Y is less than or equal to 20. Y is greater than or equal to 5. Okay, I'm going to do 3 colors. Green, blue, pink. Okay, here we go. Sorry, now you can see it. You know, for this first one, I could find my intercepts because I have to graph them all. So I'm going to do my x-intercept, means I'm going to plug 0 in for y. 20x plus 10 times 0. I don't even need to write it. If it's 10 times 0, why am I even writing it? 20x is greater than or equal to 200. X is greater than or equal to 10, right? That means that I'm going to have an x-intercept of 10, 0. My y-intercept, make sure you can see this. My y-intercept, I'll plug in 0 for x. 20 times 0 plus 10y is greater than or equal to 200. 10y is greater than or equal to 200. Then, let me try and tilt this a little bit because I'm looking at you sideways. Okay, that's better. Yeah, okay. Y is greater than or equal to 20. I think so. 20. 0, 20. Okay, now I got to figure out what the shading is going to be for that. So here we go. If I have a point at 10, 0 and 20, man, I don't have enough spaces for 20. So maybe 4, 5, 6, by 2s? How about 2s? 2, 4, 6, 8, 10, 12, 14, 16, 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay. Now, I had greater than 10 and greater than 20. That means that the shading is going to be greater than for this line. First, let's make the line green. Green. Okay. X-intercept is 10. Y-intercept is 20. Is it solid or dotted? Look at greater than or equal to, greater than or equal to. Solid. Remember how I said since they're both greater than or equal to, it's going to be shading up? So like here. All right, now I have another one. X plus Y is less than or equal to 20. So minus X, Y is less than or equal to negative 1X plus 20. That's fine, okay? Blue. So I'm also at 20. Less than or equal to means it's going to be a solid line. My slope is down 1 over 1. Since I'm going by 2s, it can also say down 2 over 2. Down 2 over 2. Down 2 over 2. I mean, I could go down 1 over 1, but then I have all these like little less than or equal to. So connect your dotted line. Oh wait, this is actually solid. This is solid. My shading says less than or equal to. Shade below this blue line. So right now in common is this triangle right here. Last one, pink. Y is greater than or equal to 5. That's here, 5. Greater than or equal to, solid line. Greater than. Okay, now I only care where they're in common. I don't care that there's pink shading over here. That doesn't matter. I care where they're in common. So I'm above the green line, below the blue line, and above the pink line. That's all only right here. Okay? That is the graph of my Malcolm problem. Dog walker, lawnmower extraordinaire. All right. Write a sentence showing how Malcolm can meet his goals. That means that in this ordered pair here, like any of these dots right here, so that'd be like 12, look at this, 12 hours, and then like any of these ordered pairs, like let's say I chose like 12 hours, 7. That's here. Okay. What was my X? What was my Y? X, mowing lawns. 12, X, mowing lawns. Malcolm can spend, remember this is just a sample, 12 hours mowing lawns. My Y value is 7. What's Y? Walking dogs. 7 hours walking dogs. Okay. If he spends that, he will meet his goal. If he spends his time in that way, 12 hours and 7 hours. And then he's still under 20 hours, so that's good. Okay. Shading all in common. All right. Solve a system with 3 variables. You're going to need more paper. Get out paper, guys. All right, let's talk about this. I'll readjust. I'll do my best because I want you to be able to see everything that's happening here. Let me rewrite it on this paper because I think that you need this space. It's really important. Okay, let's see. All right. 2x plus y minus z. Can you make your z look like a z? Do not make your z look like a 2. Be very careful with that. Negative x plus 2y plus z equals 3. X plus 2y plus 3z equals 13. Okay. 3 variables. When I have 2 variables, usually the easiest thing for me to do is elimination method. An elimination method is when I do something like make both of the x's the same number so I can cancel them. Or make both of the y's the same number so I can cancel them. Make both of the z's the same number so I can cancel them. I right now see some really good looking stuff. Here's the good looking stuff that I see. I see that my, let's call this A, B, and C. My A and B could have the z's cancel out right away. My B and C have x's that could cancel out. If I changed the signs, my y's could cancel out, but then my x's wouldn't. So you kind of have to like look at what we're gonna do. So here's the first step that I'm gonna do. Now, this is just the method I'm choosing to do. I know that there's gonna be other ways that you could start, but here is the way that I'm choosing to start, okay? So I am just gonna start in the first 2 that I see. Look at those z's. Check out these z's. These could cancel out. So my first step is gonna be that I'm going to add A and B together. Write down A, write down B. Okay. Right away, I see that my z's are gonna cancel, and here's what I'm gonna get. So I add A plus B. 2x plus negative 1 is x. 1y plus 2y, 3y. Negative z plus z, nothing. Negative 10 plus 3, negative 7. Oh, and if you mess up on a sign, it like throws the whole thing off. Be really careful. Be really careful. Okay, I just made, let's call this equation D. Okay, so I added A and B and I got equation D. This right here doesn't mean I can do something. What it means is that I need to get another equation that has an X and a Y. If I get another equation with just an X and a Y, I'll be able to put this one together with that one and cancel something out, okay? So here's what I'm gonna do. I'm going to do canceling out X and Y. I'm sorry, canceling out Z's. So you just kind of look. Look at B, it has a Z, and look at C, it has a 3z. If I made both of these 3s, I could cancel out the z's. So what I'm going to do is I'm going to multiply equation B by -3, and then I'm going to add B and C. So this required me to think like 2 steps ahead, and that's what this is all about. These are not quick and they're not the easiest. If I get this Z to be a -3 right here, then I could cancel out B and C, the Z's. So I'm going to do that. -3 times B. And I'm just going to write the answer right here. -3 times -x, 3x. -3 times 2y, -6y. -3 times z, -3z. -3 times +3, -9. This is my new B, my new B. I could call it E, I could call it something else, but it's my new B. Now I'm going to add my new B, because I just multiplied by -3, I'm going to add it to C, plus C. Here's C, x plus 2y plus 3z. Because I did this, now I can cancel out my z's. 3x plus x. -6 plus 2. -3z plus 3z, 0. -9 plus 13, 4. Man, that's a lot of 4s. Okay, I'm going to call this equation, this new equation E. Look at D and look at E. They both have an x and a y, x and a y. Sadly, my x's aren't both 4s and my y's aren't both anything, but I could make it that way, and I'm going to. I am going to make D have a -4 in front so I can cancel out 4x and -4x. So I'm going to multiply D by -4. -4 times D. Ready? Stay with me. Are you still alive? Don't give up on me. This is a lot of work. They always are. Three variables. It's just one of those problems that takes time and a lot of thought. So -4 times D. Here's D. -4 times x. -4x. -4 times 3y. -12y. -4 times -7. -4 times -7, +28. Yeah. Now D and E, let me rewrite E again. 4x minus 4y equals 4. I'm going to get one variable by itself. So here's the deal. It took that long. It took all this time for me to get y alone. It's true. It's hard. Yay, my x's cancel. -16y equals 32. Divide both sides by -16. Y equals -2. Okay, I'm going to go up here. X, Y, Z. Guess what? It's all downhill from here. It's all easy from here because I've got the variable y. I know that y is -2. So I could go back to D or E and plug in the -2 for y. Let's do it. It doesn't matter. I think D. Plug -2 in for y in D. X plus 3 times -2. X plus 3y equals -7. X minus 6 equals -7. Add 6. X equals -1. Oh, yay! I have X. I have Y. Now all I need is Z. It's easy once you get one of them. Once you get one of them, you're golden. It's so easy. The only place that Z is located is up in my originals. So you just pick whichever original you want. I think that B looks like the easiest original. So I'm going to plug -1 for X, -2 for Y into B. Okay, B. Here's, oh, can you see them both? Yeah, kind of. -X. -X, be careful, plus 2y, -2, plus Z equals 3. 1 minus 4 plus Z equals 3. -3 plus Z equals 3. Add 3. Woohoo! Z equals 6. What do you guys think? Is this your favorite? Should I give you 10 of these tonight for homework? I won't. I would never be that mean. Because instead of learning how to do it, you get sick of it and you would hate it. So I think like 2 is good. But you know what still is hard about this? You need the guidance on, what do I do first? How did I know that I would choose B and C? How did I know that then I would combine D and E? That's the part that's tricky. So this is just problem number 6. Okay? Pause it at any time if you need to pause the video. Okay? So, last one. Totally different, but it involves systems. A matrix is a rectangular array of values. So I can have a bracket full of numbers, and I would call that a matrix. Your equations must be written in standard form, and you show all the coefficients, the numbers that are in the system. A dotted line separates the solution. Okay? So here we go. If this is my system, the 2 and the 4 and the 3 and the -2 and the 1 and the 10 are all I care about. Here's my X's, here's my Y's. 2, 4, 3, -2, 1, 10. Instead of an equal sign though, I just make this dotted line. So this guy right here, I call an augmented matrix. Okay, it's changed. So the only one I'm giving for you is for you to try putting this in. Please notice that the number in front of X is a 1. There is no Z. It's not going to be a 1Z. It's going to be like a 0Z. So this is a, ready? Top line. Dotted line separates. Answers go here. X coefficients, Y coefficients, constants. Okay, ready? Coefficient of X, 1. Coefficient of Y, 5. Forgot Z. There is no Z. This would be like 0 times Z. Okay. Second row. X is 3. Y is -2. Z is a 1. X, Y, Z again. X, -1, -1. 9 under my Z's. Okay, I got my X, Y, Z's. Now let's do our after the equal signs. 4 goes with the top row. -6 goes with the middle row. 11 goes with the bottom row. So all you're doing in this problem is rewriting a system in an augmented matrix. And that's what this is, okay? You're rewriting the numbers. X, Y, Z, equal sign, and then your constants, your answers, your numbers, okay? So we did 3 things today. I gave you a word problem, and there were 3 inequalities, and you graphed them all and shaded. I gave you a system with 3 variables in it, and we learned how to manipulate it, change numbers around so that variables would cancel. We also talked about matrix and how to just rewrite a matrix. Okay? All right. So you're not going to do homework right now. All you're going to do is watch this video and take notes. I am going to work with you on Tuesday during class to do sample problems. And guess what we're going to spend a lot of time on? This guy. Okay? You come with your questions because I will answer your questions to the best of my ability. Okay? All right. Whatever day it is that you're watching this, you guys, have a great rest of the weekend. And I will see you on Tuesday. All right. Bye, you guys.